So this one goes out by request. A lot of people are asking me, hey, how do you find the derivative, of a function that is basically, you're going to have to utilize the chain rule nested within the product rule. So I cherry-picked number 63 here. You definitely have to use the product rule, and guess what? You have to use the chain rule as well. So I wrote it, y equals x times 2x plus 1 whole thing to the fourth. I wrote it here on the next page. Let's start by finding the first derivative together. The author wants us to eventually find the second derivative as well, but notice how I'm going to kind of chunk this off so you can understand my language. First function, and then I'm going to chunk this off right here. If you can view it in your mind as, the product of two functions, g of x and h of x, you can quickly utilize the product rule. So first times the derivative of the second plus second times the derivative of the first. And you always want to recite that to yourself. So, okay, so y prime is equal to the first guy, that's x, times the derivative of the second, which we're going to have to use a chain rule. So hopefully you're thinking that's 4, 2x plus 1, whole thing to the third. But then chain rule says times the derivative of this here inner piece, which is the derivative of 2x plus 1 is just 2. Okay? So again, first times the derivative of the second plus second function, which is just 2x plus 1 to the fourth, times the derivative of the first function. And again, the derivative of x is just 1. Okay, so I always, whenever I'm taking a derivative using a product rule, I sort of sing it to myself. First times the derivative of the second plus second times the derivative of the first. Okay? If you arrive here on a test, it makes me happy. But, it's not clean to the point of the author. It's like if you check your answer in the back of the book, it's not going to look like that, right? You got to clean it up. So, let me grab another color here. Green, haha. So, 4 times 2, let's practice cleaning, is 8. And then times x is 8x. Okay, so, because they're all connected with multiplication. So you have 8x and then paren 2x plus 1 whole thing cubed. Plus, and over here we luck out because 1 times anything is itself, so we just have 2x plus 1 whole thing to the fourth. Now here's the kicker. If you look up in the back of the book, the author is still not going to have this as the final answer for the first derivative. What they do, and this is the part that really gets people, what they do is they in essence see 2x plus 1 whole thing cubed. They see that as the GCF, because you've got 2x plus 1 to the third power, but then you've got 2x plus 1 to the fourth power. So that, entire binomial raised to the third power is the GCF, and you're going to factor that out. So 2x plus 1, whole thing cubed, and then what I like to do is big old bracket or big old parenthesis. You're going to be left with 8x plus paren, and you're going to be left with one of those, 2x plus 1. Now, if you keep cleaning that, notice 8x and 2x then added together, this makes 10x. Aha! So you're going to have 10x plus 1. Times over here 2x plus 1 whole thing cubed. So I'm actually going to write that on the next slide. So let's see, 2x plus 1 cubed, 2x plus 1 whole thing cubed, and then let me re-record that, and then 10x plus 1. See how it cleans so nicely if you pull out that GCF, meaning y double prime is note to self, prettier. If algebra can be pretty, which it can. So it's prettier to look at when you, again, that business about pulling that out as the note to self, GCF, pulling out the 2x plus 1 cubed as the GCF, pull that out front, and see what you're left with. If you do that, that's going to enable you to clean up y prime to the point where it's going to be easier to take the second derivative as well. So, okay, so here we are. Now we're ready to run that second derivative. Y double prime. Now I'm going to grab another color here. Let's say black. Okay, see, now we're ready to use the product rule, and so I'm going to call this first guy, and this one second guy. So first guy times the derivative of the second plus second guy times the derivative of the first. And I'm using informal language just to make it sound easier. Okay, so first function times the derivative of the second function, which is 10, plus second function, this guy here, 10x plus 1, times the derivative of the first, but the derivative of this thing is going to be a chain rule, right? So it's going to be like 2x plus 1 squared. But then times, chain ruled out, so times the derivative of this inner core here, which is just 2. Okay, now you want to clean that. It's all about just making it look a little bit prettier, okay? Typically 10 is like a coefficient, so typically you're going to pull your coefficients out front. It's like style. I always say style-wise you're going to pull that coefficient of 10 out front just to make it look a little cleaner. And then here, you know, you've got this floating 3 times this floating 2. Let's clean that a little bit. You know, let's call that 6. Okay, so we'd have 6 paren 10x plus 1 paren, but then we'd have your, 2x plus 1 whole thing squared. Okay, now, if I'm grading your test, I'll be happy with that, but you guaranteed the author's going to take it further, keep cleaning. So we could keep cleaning. Let's do that. We'd have 60x plus 6, times 2x plus 1, whole thing squared. And what they do is they're continuously using that idea of the GCF, which we talked about earlier. They're really always extracting that GCF. So let's see if I can highlight that in another color. Okay, so basically here you have a 2x plus 1 cubed, but here you have a 2x plus 1 squared. So the greatest common factor, the GCF, is would be the 2x plus 1 whole thing squared. So let's kind of pull that out. 2x plus 1 squared. I'm going to write that on the next sheet. Oops, got small. So y double prime then, I'm going to pull out the 2x plus 1 whole thing squared, and then I'm just going to kind of record what I'd be left with. Let me go back. So if I pull that out, I'm going to be left with a 10 and then like a 2x plus 1. So I'm going to be left with a 10, a 2x plus 1. I'm chunking that off in parentheses. Let me go back. And then a plus sign. And then, I pulled this whole thing out here as the GCF, so I'm only going to be left with this. So plus 60x plus 6. Plus 60 paren x plus 6. So I had to keep moving, the slide around, but basically note to self GCF. This, I had pulled this out as a GCF, and I would have been left with the 10, an additional factor of 2x plus 1, and then the quantity 60x plus 6. Oops. And I just noticed I wrote that quantity wrong right there. The quantity 60x plus 6. Now, even within that, you can still clean. Algebra is like a cleanup process, right? So 20x plus 10 plus 60x plus 6, all within there. And then 2x plus 1 whole thing squared, and that's, we're still cleaning on our y double prime there. Keep cleaning in here. So that's a 80x plus 10 and 6 makes 16, and that's a 2x plus 1 whole thing squared. Now a lot of people, and that's fine, you've cleaned that enough there. A lot of people say, well, why does the author keep doing that business with, pulling the G? Now you can see why, because if for some odd reason you were forced to find y triple prime, which could happen, But if you were forced to find y triple prime, then you'd just go ahead and, you'd be using another product rule. So, hope you understand how the author's getting what they're getting now. Okay? Good luck.